So equations, making things subject to the formula, it's all really the same thing. It's just moving bits of algebra around. Now, not exactly the most mind-boggling question that there is, but more to illustrate an idea. I don't know how you were first shown how to solve equations. There are all sorts of things where people say, oh, well, what you do to one side of the equation you do to the other, and things like that. When I was taught about equations, first of all, I was taught the idea about moving terms. So you want all the pronumerals on one side and the numbers on the other side. I'd really like that 3 to go over to the other side. And the rule was, if you move a term, you change the sign. So the equation became x equals 6 minus 3. And then, of course, 6 minus 3 gives you the answer of 3. So that's sort of how I was introduced to equations, using that sort of idea. With something like that, 5z equals 45, well, you want to do the opposite operation. It's 5 times z. The opposite to multiplication is, of course, division. Look, the division symbol you should very rarely use. Okay, it's a lovely little symbol. But the fraction bar like that is an alternative to the division symbol. And it's a more useful alternative. I mean, in this case, yes, it does simplify down. But if it didn't, bang, you've got the answer already. Say the answer was 3 on 2. I've got the answer already, you beaut, I don't have to do anything else. If I had written 3 divided by 2, then I've got to go and do something. So, I mean, that's the whole point of the vinculum, the fraction bar. It is, in fact, another division symbol, another way of writing division. And, of course, 45 divided by 5 is 9. Parentheses, you can expand out first, then tidy it up, or I could divide both sides by 4 and go from there. I wonder which way I did it. Expand it out first. Okay, so it becomes 4a minus 20, move the 20 to the other side, divide by 4, and bingo, there's our answer. Then we introduced ideas, well, no, pronumerals on both sides. How are we going to do that? But as I say, all we're really saying is, hey, I want all the numbers on one side, I want all the pronumerals on the other side. I'm just going to move these things. So it becomes 2z equals negative 11 minus 11 on 2. Here's another point. Improper fractions, mixed numerals. Who would now go and write that as 5.5? Anyone? Good. 11 on 2 is perfectly fine. It is a number. I don't see why we would waste time and write 5.5. I suppose the only time I would is if it had meaning to do that. Maybe we're talking about a measurement question or something. They say, how long is it? And okay, it would be more natural to say, oh, it's 5.5 metres long, rather than saying, oh, it's 11 on 2 metres long. Okay. Mixed numerals in that case makes sense. But when we're just talking about numbers, 11 on 2, 5.5, it's the same thing. Why do extra work? Okay. Oh, but yes, then we introduce pronumerals on the bottom of the fraction. Oh no. That's all right, we've got to get our common denominator. But rather than doing that, because I hate working with fractions, and I'll be honest, so the first thing I like to do is just get rid of the fraction. And so that common denominator of 7y, rather than just making both fractions 7y, I just multiply everything by it and get rid of that denominator. So it becomes 5, 14, and on the right-hand side, we get 21y. And there we go, 19 on 21. Oh, fraction equal fraction. Point this one out. Of course, the quick way of doing fraction equals fraction, cross multiply. Cross multiply. So we can multiply along the crosses, and it becomes 3x plus 9 is 10x minus 30. So that's that specific case when we have fraction equaling fraction. And we end up with, there it is, 39 on 7. Okay, now let's talk about inequations, inequalities. Basically done exactly the same as equations, as you know, other than we have to watch out for some things. If you multiply or divide by a negative number, you've got to change the inequality sign. So the way I remember that is very simply, if I change the sign, I change the sign. Okay? You change the sign of the number, then I'm going to change the sign of the inequality as well. So if you change the sign, you change the sign. The other situation, it doesn't happen that often, but if you're dealing with one and you take the reciprocal of both sides, then you need to change the inequality sign as well. But as I say, that's fairly rare. Again, not a mind-blowing question here. So we just divide both sides. This is more now onto how we would write this solution, or graphically. In other words, putting it on a number line. I mean, x is less than 6 is an algebraic solution. A geometrical solution would be a picture, and as we know, we would, in this case, just circle, you're right, we would just circle the solution. We leave it unshaded to indicate, hey, not included. And then we would put an arrow indicating which way. There. Now, this is where the controversy is. Some teachers are very fussy about different things, and they'll say, no, you can't put that arrow above the line. It should be on the line, no, not above the line. And I disagree with that myself, because I think, well, if you put it on the line, sometimes you lose it because you can't tell what's the actual line and what's the arrow. As long as it's not ridiculously above the line. I have seen some people go, all right, from the dot I'll go up vertically and then across. I know that's just ridiculous, but just a nice simple one, so it demonstrates, yeah, these are the numbers that I'm talking about, the ones to the left-hand side. Okay. Difference between equations. Equations, we normally just have one equals symbol, whereas with our inequations we could have 3 sides, not just 2 sides to it. But the rule's still the same, but rather than saying what we do to one side we do to the other, I guess what we say here is what we do to one thing we do to everything. So let's solve this one. First thing I'm going to do is move the 6 to both sides. So we get negative 4 and 8. Now I'm going to divide by negative 4, but of course if I change the sign, I change the sign. This is where we break out into a cold sweat and look at it and go, oh my God, no. Whew, that's better. I mean, look at it, one is less, it's not natural. I mean, negative 2's on the left-hand side of 1, it just, doesn't it look so much nicer? I mean, that's a more beautiful solution. It looks like the number line, because if we were to draw it graphically, there's 1 and negative 2, it looks like the picture. There's 1, there's negative 2, I'm in the middle. So a much nicer way of writing that would be to have the numbers in the correct order there. Notice I haven't bothered putting naught. Some people have this obsession with, if I've got a positive number and I've got a negative number, for some reason I have to mark in where 0 is. I don't know why, I don't know what this obsession is with 0, but there is no need if you're one of those people. Alright, here we go, the Mr. Simmons fussy rules. The correct, what Mr. Simmons says, the correct way of writing inequalities. So if we have something like that, there's the geometric solution, then that is x is greater than 5. It is not 5 is less than x. Remember, you are giving a solution to the problem. The problem would be, what are the values of x? What values can x be? And you're answering, x can be greater than 5. That's the correct way to answer that. Saying 5 is less than x doesn't answer the question. It's still not telling me what x is. Oh, 5 is less than x, that's fantastic, but what's x? Right? So we should have x on the left-hand side in that one. If it's in between, so something like this, and I've made one an equal to and one not, then I would write it just like the picture looks like. 4 is less than x is less than or equal to 6. We would not write it this way because it doesn't look good. It's horrible. All right? You get nightmares when you start thinking about things like that. You definitely don't write something like this. Right? Because x equals, let's say 1000 is a solution to that. Think about what it's saying. X is greater than 4 or x is less than or equal to 6. Well, 1000 satisfies that because it is greater than 4. Because you're saying or. If for some reason you didn't want to write it, you'd have to use the word and, not the word or. But it's just neater to write it in one little piece. So no, we wouldn't use the word or in that case. Bad, that's just wrong. That's not just me being fussy, that's just wrong. Okay, So what about when we're out on the edges? When we're out on the edges, then that's where we would use the word or, because it would be impossible to use the word and there. You find me a number that's both less than 4 and greater than 6. I mean, you can't do it. Right, so that is a correct use of the word or in that case. Yes, this one is me being fussy. I just think that looks silly. You know, x is greater than... No, 4's on the left-hand side of 6. It just looks nicer the other way. And this one is just plain wrong as well. I see people trying to do things like that. 4 is greater than x and trying to combine it into all one thing. No, that one's just wrong. Wrong. Can't write it like that. Alright, so there's our little recap on equations and inequations.